So I had a little issue. Stopped the video earlier. So we noticed that we have this second derivative of charge with respect to time plus some constant times charge equals 0, which means it has to be a simple harmonic oscillator, meaning the junk that I've drawn a box around must be omega squared, meaning that using Euler's, why did I just write the word Euler's? I meant method. Using Euler's method, you can make up a test function. We know that we've used cosine before, so we know that charge as a function of time is the maximum charge times cosine, just like with a spring, like a mass on a spring, same deal. Well, we know that current is equal to dq dt, that's a q. That's dq dt. So now we can take a derivative of this. So that's the maximum charge times negative omega times sine of omega t, right? So what we're looking for is I max. Well, I max has to be when q max times omega times 1, right? So that's going to be, let's remind ourselves of a couple of things here. The omega that we just wrote is 1 over square root of LC, right? Omega squared is 1 over LC, so omega is 1 over root LC. And a capacitor is defined as the charge divided by the EMF. So that means that capacitance times EMF is charge. So let's rewrite this. I max for our circuit that we're doing here, which is a oscillating LC circuit. I max is going to be equal to let's get rid of Q max and replace it with our C times E over the square root of L times C, which we can rewrite as the EMF times 1 over root L. Let's leave that alone for a minute. And then C over root C, which can be rewritten as EMF times the square root of C over L, right? C over root C is the same as root C. So the maximum current in a simple harmonic oscillating LC circuit is always going to be this function. The EMF that you have times the square root of the capacitance, which is a constant, divided by the inductance, which is a constant. As a reminder, inductance is always going to generate EMF to fight the change in current. Okay, hopefully that explains it. By the way, that was one of the questions from the 2018 International Practice Exam, if anybody is curious. Okay, bye.